Welcome to this talk. I would like to talk a little bit about, Java applications, Java developers. Anyone? Good, perfect. I always start with some kind of stupid question or a kind of obvious question just to make sure that the hands are working. So keep using them. I want you to use them, and I want this to be all my talks. I really want to be a more interactive thing instead of me broadcasting and just telling you things and you just receiving things. So throw questions at me at any time, stop me at any time, or whatever. I'd like to talk a little bit about Java applications and Java applications, what really makes them different from what we used to. So it's kind of getting more and more scary to think about the time I started working, because it still feels like it was yesterday. It was almost 20 years ago now. So I started as a Java developer. I started actually as what now it's called full stack developer. That time we actually didn't have that term. But I was doing backend on Java, and I was doing front-end stuff, and I was doing all these kind of things. And it was Java then, it's Java now. What is the difference? And this is a bit more one of those things that I'll be talking about. Another thing that I'll be talking about or showing you is a kind of opinionated version of, because I have had to create a demo, I had to pick a platform, I had to pick some libraries and runtimes and things like that. So for obvious reasons, that is opinionated. But a lot of things that I will be mentioning you will be able to use in other frameworks or runtimes or whatever, because those are kind of more generic concepts. So that was a little bit of introduction, and as all good programmers, we start counting from 0, and I promised you 5 things. You will still get 5, so this is like extra. So we're not going to stop at 4. Kind of off by 1 error, I don't know. I want to start with this slide, and I usually ask people, Java EE, anyone? Good. Jakarta EE, anyone? Technically, it's supposed to be at least the same set of hands. Because, well, and that's kind of funny. It always works like this. Because at some point, that changed names, but it is pretty much the same thing. It started as JPE, J2E, Java EE, and all these kind of names and weird things. And then at some point, they gave it away to Oracle. After acquisition of Sun, they gave it away to Eclipse Foundation. Now it's one of the things that they had to do was to change the name. That was kind of the thing. You can't use Java anymore because, well, Oracle owns trademark and all that. So it became Jakarta. And that's one of the things that I'll be talking about. That's one of the aspects that I'll be mentioning. But if you are using Spring or anything else, that's fine. You'll be able to find all the same similar things that I'll be talking about there as well. And speaking of, so I don't know how many of you remember the story of this timeline and all that. There was a big hole somewhere in the middle between the change of the names, where Oracle still had that thing and nothing really happened, and a lot of people got nervous and they were like, what's going to happen with our stuff, because we're still running on the enterprise Java libraries and all that, but it's not getting enough love. So they created another thing that we'll talk in a second. So there was another movement or another kind of community thing that was created on this. But before we do that, I need to explain what is that thing. So Jakarta 10, the latest one, 11 is just around the corner. They're just a little bit late with a few like TCKs and tests and stuff like that. So it was supposed to be released, but it's not released. So that's why it's still not on the slides, but it will be there. Anyway, in version 10, they did split it in 3 different profiles. Core profile, web profile, and the whole thing. And the thing that we're really interested in is a core profile, because, I'm not going to talk too much about this for a few more minutes, and then we'll get to the actual thing. What I want to say is that with core profile, or generally with Jakarta EE and all those libraries, is that it's a set of specifications with the things that are useful for you when you create microservices. And modern kind of cloud-native applications usually are at least, I mean, they do not have to be a microservice. They do not have to be on a cloud, but they usually have some kind of things that will simplify that process to be in the cloud, to be as a microservice, to be on Kubernetes or whatever. So, as you can see here, it's very, basic-ish stuff for services, right? You have like JSON bindings, you have dependency injections, JSON processing, and all this kind of stuff. This is core profile, right? And now over to the thing that I was talking about. So, while Java EE at that point was not getting enough love, people got together and created something called microprofile, where they put together a bunch of libraries that are very useful for microservices. I mean, if I go back and you see all those grayed out things that we're not going to talk about, there is a lot of stuff that is very useful, but not for a microservice typically, not most of the times anyway, like email things or mail things or batch processing and all this kind of stuff. Normally, you don't need that. But you need things like fault tolerance, you need some security and login stuff, you need configuration stuff and all this kind of things. And so they created something called microprofile. They just released version 7 of that thing. There are alternatives. There are Micronaut. There is Spring Boot. There is a bunch of others. If it doesn't matter which one you use, all of the things that I'll be saying and I'll be explaining and talking about can be applied there as well. Right. So that's a little bit of a story, right? And then as you can see, core profile, Jakarta EE 10 core profile, that's a little box there. And it adds a few more things next to it. So things that it doesn't have. So REST client, so you don't have to program all the REST calls and parsing of JSON and stuff, and Open API specs and all that. And there is also metrics was part of that for until version 6, and at 7 it kind of moved into standalone part, but it's still part of that. And then you can do like GraphQL and all the other fun things that we're not going to talk about, but kind of fun to look at. Wall of text slide. So wall of text slide is there for just one reason, and that's the reason to show you that all of that I've been talking about, Jakarta EE, microprofile, all that, is specification. It's up to actually providers to implement that. When somebody says, hey, we are Jakarta EE compatible or microprofile compatible, that's basically because they have been passed through a bunch of tests. They have gone through a bunch of verification things, and they actually satisfy the requirements. So it's a kind of a good thing because you can actually always see and see into the documentation how everything is supposed to behave. And we'll see that in a little bit as well. I put a very short, very handy URL. It's very easy to remember, very easy to type. So that's why I put it very conveniently on a side there. Probably you don't want to type. It's probably easier to Google, or whatever search engine you're using. But it's there. It's out there on the interwebs. Okay. Enough with the introduction. Let's talk a little bit about those 5 things that I've been talking about. One of the things that we really, really need to do that, and I work as a consultant. I've been doing that for, almost 20 years. I go to customers and I try to help them with their problems. Usually it's something that they already have and stuff like that. And very often, this is one of them. It's like they have a bunch of microservices, bunch of sometimes even nano services, and something fails, everything else fails. It's like a house of cards or dominoes or whatever, and everything just keeps on kind of crumbling together just because something failed. If you look at a lot of postmortems of a lot of things that have been happening, not necessarily like lately. I think big companies got a little bit better at that, but still, usually something fails somewhere inside your system. Some other systems try to ping that, retry and retry, DDoS itself, and then everything goes to, a very wrong place. So you need to think about what happens with your application with something that you rely on fails, right? So this is basically the selling point, right? And why do you want to do that? Well, because I don't know how about rest of you, but I do write bugs sometimes, unintentionally, but it happens. I know that there are people that do believe that they don't, but good for you. But for the rest of us, we do need to kind of think about that. So we need to be able to actually handle the things that go wrong sometimes. Sometimes it's not even you, it's your colleague. Huh? Better? Yeah, see, now you're like, relieved. Good. Or your customer or consultant, the evil consultant. Anything, whatever floats your boat, it's fine. Somebody wrote a bug, you need to handle that. You need to switch to a backup solution because some endpoint that you've been using is down. And you really need it, but you can't do anything about it. It's out of your hands and all that. You really need to somebody else to reroute your calls to something else, maybe less reliable, maybe less accurate, whatever, but still it works. So that's the other thing. And well, we talked a little bit about DDoSing your own application. That's not very fun. I mean, it has happened. And it's also like very, very sad when you have a chain of microservices and one thing fails and then everything just goes bad. And that kind of sucks. That's really, really not so fun. In the microprofile spec, which is, again, very conveniently placed, very simple, easy to remember URL, I did not put QR codes for a reason because, I mean, again, you can search them up. You don't really need that URL, but I'm just saying that it exists. They do specify those annotations. So as with Java EE, you work with annotations. If you're doing Spring Boot, Micronaut, all the other things, you might do it in a little bit different way, but still you will expect something similar there as well. You have timeouts. You have also option for adding retries. You have an option for creating fallbacks. We'll have a look at that in a bit. And you also do circuit breakers, because sometimes you don't want to keep on retrying. You just want to, okay, we've tried all that. Now we're just like going to go do something else. So, yeah, you have all those things, and you should be able to do that. Now you're probably thinking, well, that's obvious. I mean, of course we should. Believe me, most of the people, most of the code I've seen, they don't. And it fails. And it doesn't work. It just breaks a lot of things. So just tiny little piece of code, tiny little timeouts, retries, fallbacks placed carefully in the code will save a lot of time and a lot of frustration as well. So I do have some code, and I do actually have live code over here. But we'll get there in a second. So for now, I'm going to show you some dead code. I mean, not live code, whatever the opposite of that is. But you have two endpoints. You have message and you have message backup. And this is those two that you want to do. And then you actually create a fallback method in the first one saying, well, you know what? If /message fails, go to message backup. And here, it's actually just the definitions of the endpoints that you will be calling, because here we're actually, on top here, we're actually creating a REST client. So this is, as all architects, and nerds, obviously, I have created a architecture drawing in ASCII art, because PowerPoint is not fun enough. So imagine you have this situation. You have a service A and you have a service B. I called a service A for kind of just service, because that's the one you're calling. Call it backend for frontend or whatever. And there is an actual backend for that service. It's calling something on the backend. That's service B. I do have a little thingy down here, but ignore it for now. We don't think about it for now. We're looking at this too, and it has a few endpoints. So the service A, the front service, it has a hi and a feature, and the other one has also an API. So it has an API message and API backup message there as well. So this is the complex architecture we're working on, right? What you see here, that's the REST client on the service side calling the backend. The backend looks kind of like this, and I had to implement, so I wanted it to fail from time to time, and this is how I did it. So I roll a dice. If it's divisible by 2, no errors. If it's not divisible by 2, it does fail with a very informative message saying some weird error. It's going to be like, I'm going to show you things that you should do in your project, and there's also a bunch of things that you should never do in your project, like, for example, writing messages like this. But, you know, it is what it is. You had to create a demo, which is simple and all that. When that fails, I have a backup endpoint, which says a backup hello. So one says hello there, the other one says backup hello. And this is all. We can look at it in, where is it? There. So this is our front end, so we'll do hello. And if we keep on refreshing, this will always be saying everything is fine, right? So never, it's not failing at all. If we do a little bit of magic, very informative feature. And then wait a few more seconds, it will probably start failing at some point very soon. Yes, now see? So user does not see a difference. So this is you on your front end calling, and you would not even see the difference. You still are getting responses, but sometimes you're getting backup, sometimes you're not, and this is kind of random. But if I wouldn't put the backup message in the string, you would not really see the difference, right? So it's really nice. So think about this. You really should add some error handling and make sure that it actually does what it's supposed to do. So that's one thing. Next thing I want to talk about that is also a bit different from the way we used to do applications a long time ago to what we should be doing now is to be able to expose information about applications. So what's happening inside your applications, and that is it's a thing of telling your, because, okay, now we're creating cloud-native applications, right? Imagine that your application is running on a serverless endpoint somewhere in a container, in a cloud, somewhere out there. There's a lot of things that has to happen when you send a request to that application, because that application has been set up, let's say, to scale to 0, so it's not really running, it's not doing anything, it's been hidden somewhere and sleeping. A request comes in, cloud needs to figure out where it's supposed to go, needs to copy the container image from container registry, deploy that, start it up, make sure that it's up and running, ready to receive requests, route that request to this thing, send the request response back, and then you actually see what's happening, right? So it's a lot of things that has to happen on a system like this. If you're running Kubernetes, well, still it will be the same thing. It needs to find the right pod, write everything, send your response. So when a container starts, you need to understand if your container is up. Then you need to understand if your application is up inside your container. And you need all that to, and if it's healthy, right? Because you need all that to first be able to route requests. 2, you might want to create some rules to scale. And 3, you might want to know if your application is healthy so you can kill the container and create a new one if it's not responding. And this is kind of the ping. So you have different probes to be able to do that. And this is how you can create your own, write your own probes for applications to answer all those questions, really. You have 3 different probes. Typically, that's readiness, startup, and liveness. So, well, liveness, that's kind of obvious. Are you alive? You just poke it with a stick and just see if it is doing something. Startup and readiness, that is, yeah, so if your container started up or if you're actually ready to receive requests. Because when the container starts, it doesn't mean that your application is started, because it still has to boot up inside there. And also, it applies for not only cold starts, that means starting from 0, but it also means that you need to think about that when you're scaling as well. So if you had like 1 container and you have a lot of traffic and you need to do 4 containers, you need to understand at what point you should send the traffic to the other 3 that's just being created. Next thing, I'll do the demo. I'll show you the demo and show all these things at the end. Or actually, you know what? Let's do this. So we talked about health. The cool thing is that in this, with the microprofile, it is already automatically available. So I can go to /health and I'll have all that. So I created a bunch of health checks, and I also created some health checks that, for example, will fail when the response time is too low. And I can try to show you that. Let's see. If I turn on this, so I created delay. So now I just have basically I have a dumb function that does go to sleep for 5 seconds and then before it responds. So now if I refresh that thing, you see it's up there. If you can see it, if it's still spinning, so it's not got any response. And now I got one of the checks is actually failing because it says, well, critical service high, because it's very critical for my demo. It's too slow. And this is just some Java code that I've written to do this kind of things and to automatically expose that data. And when Kubernetes or whatever is running, my application is running on, can seize that, because this is a standard stuff that is expected, or it's kind of easily ingested by the platform you're running on. When it sees that, it will know what to do. It will know what will try to kill it or restart it or do whatever you tell it it's supposed to do. So if we remove delay again and refresh at some point, so it takes maybe a few seconds for the feature to be refreshed. So still failing. Now it shouldn't fail. Yeah, now it's back in business. So now I can refresh it as much as I want. It works. Okay? So now I'll show you some code and stuff like that at the end. And all of the code and everything that is running here, it's all on GitHub, so you can actually go and have a look at it yourself if you want. Third thing, metrics. So we talked about handling errors. We talked about knowing if your container is up and doing fine. Now we want to create some custom stuff. So you want to create custom application metrics and expose them to the platform. So, platform like whatever you're running can consume that and do something about it. It can be something based on for scaling. It can be done for something just for logging, whatever it is. And it has one standard endpoint using very standard formats. And the standard formats look like metrics. So prepare yourself. You'll see a wall of text. Don't get scared. Yeah, see, I told you. All of that's standard stuff. So that is just out of the box stuff that you can do whatever you want with, but you can also create your own. So in the backend service, I have metrics. You see the first two here? That's the one that I've created myself. So this is a counters of how many times the endpoint has been called and how many of them failed. So 68 in total, 23 out of them were actually backup hellos. How do you do that? Well, you annotate things, and you can actually annotate it as you can see here. You can actually create same counter for different methods with the same tag, or different tag, sorry. And then it will actually create, see here, I have the same name, custom messaging service total, but I do have two different tags. So one of them is purpose failover and the other one is purpose total. Probably purpose is not the best word, but well, you know, bear with me. Naming things is hard. And you can do different things. So one of the simplest things you can do is counting, and then you can also create if it is an absolute value, if it is like relative value, and all these kind of things. And again, all that is a part of specification. You can always go and look at the spec and see. In your case, if you're using something else, it will be different as well. So it will be, but same kind of things that you can expect. That being said, it's probably a very good idea to hide both metrics and health endpoints from public. So if it is running on the cloud or something, to not expose probably those. You maybe don't want to do that because, security and all that. But it's up to you. It's your application. You decide, but maybe you don't want to do that. Feature toggling. So we actually have seen that already, right? We have seen, I kind of had a sneak, gave you a little sneak peek of that. Because I've been kind of kept on switching to this little thing. It says feature toggles, so if you're a little observant, you'll probably see that. So the reasons for that can be very different. So it can be sometimes you just are not done. So I've worked in a lot of times in the projects where you would have, I don't know, let's say front-end team would do their job and be done, and back-end team is not done yet. What do you do? Do you comment out the front-end stuff and deploy a new version because the new version has to be released or whatever, and then you wait for that and create a new branch, all those things, right? The cool thing is that you can, for these reasons, you can use feature toggles. You can actually create a little toggle on the front end, say, you know what, for now this is off and all that is hidden. The code is still there, but you just wait for the backend to be done, and then you can actually flip a switch like I did here. So you don't really have to redeploy anything. You basically do a little switch like this, and it will just say, well, it's enabled and blah, blah, and everything is peachy. So turn on and off features. It can also do gradual releases, so it can also help you with A/B testing. It can also help you do it with, okay, everybody in Norway gets this feature, everybody in Sweden does not, and all these kind of things. You can do based on geographical location, based on whatever browsers, anything really. But you can also do that. It's basically your imagination that sets limits here. Any reason that you want to hide something, you can do that. But when you use that, if you're going to use that, you have to promise me one thing and one thing only. I'm going to ask you two things in general. So this is the first one. I'll ask you the second thing in a fifth point. So the first thing, promise me, put your hand on the heart and promise me, all that. Please do delete those feature toggles when you're done with them. Because those feature toggles, they're very cute and they're very nice. But, like gremlins, when you feed them after 12 and throw them into water, they do grow up to be very ugly and they become like a holy something that nobody dares to touch. I see a lot of people laughing. You probably experienced that, and it's not fun because at some point it's like, why do you have this feature toggle? Nobody knows, but just leave it. It just works. And people start praying to those things and, all this kind of things. We do not need another IT religion. So kill them. Kill them as fast and as quick as you can. All right? That's the first thing you need to promise. The second one will come soon. I've done this talk quite a few times, and people, they were like, I did this talk in Poland once, and they were like, why? We can just do ifs, put in config. It works. Why do we need a system for all that? And well, yes, you can. There was somebody that was asking really why would I need another system for this? I can just do another if and put a little config thing and whatever. Do you really want more ifs and else in your code that do weird cases? That will definitely become legacy code that you'd never dare to touch? Or, God forbid, somebody else finds it and uses it for something else, and now it becomes dependency? Or when you put it in a config file, yes, you can, but every time you redeploy, you have to redeploy it to be able to turn it off and on or change values or whatever. So it's a good idea to use a tool. Which tool? I don't care. Any tool. There's a lot of tools out there. So the reason I'm showing this one, it's because it's made in Norway and it's open source. It's called Unleash, but it can be anything really. It's for those of you interested, it's a spin-off that kind of went from fin.no. and became a separate company and all that. So, it's a fun, nice project. They also have their own cloud and stuff, but the actual code and the actual thing is free. So that's an example, but whatever you want. If you want to use, there's a bunch of other feature toggling systems. Use something. At least use something. Don't try to do it by hand, because you don't want to maintain that afterwards. And, well, it's very simple. You just do, like, in this case, you just do unleash. You create an object that you send around, and that object you just say if unleash.enabled, and then you send a variable to that thing, and then it will just do that. By the way, this is I told you a lot of things not to do in production, but this is how you remove bugs in production. Right? It's a bug. Feature toggle enabled. Well, it's a feature now. And it actually works. If we go to, well, here. Now it's a feature, see? And the cool thing is that it's really quick, because like you don't really have to wait for too long before you refresh and it becomes a bug again. Oh, come on, there. The demo effect, as always, does the opposite of what you're saying, but still, it took like 3 seconds, 5 seconds, something like that. Right. Last thing. I still have a few more minutes, so let's do the last thing, and then I'll show you some code. This is a bucket of things that did not fit in any other category, so I put them all together, shook it well. And so it's all about the environments, configurations, infrastructure, and all this kind of thing. So this is your Java applications, right? You're creating modern Java applications, not the old monoliths. And yeah, so now we're into the second thing that you have to promise me to not do. So first one, remember? Kill feature toggles, yes? Mm-hmm. The second one, that's that. ClickOps, do you know what that is? Yeah, you go to a wizard, and like we did in the fairy tales, you go to a wizard and you say create something, and you click next, 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 and then the wizard tells you, well, your Kubernetes cluster is created, your wish has been granted, and you say thank you, and you go for 7 years, and then you need to create another cluster, exactly the same one, but that wizard is gone. The system is different, everything is very different, and you have no idea what the settings were. Anyone? Feels familiar? Yes, I've worked on something like that as well. So do not do ClickOps. Whatever you do, whatever you want to do everything except that. So any kind of infrastructure as code, infrastructure as configuration, whatever floats your boat. But do that because, well, obviously it's reproducible. You can actually do it again and again and again. You can create your environments and recreate your environments at any time, and it will work. And it will be the same way every time. And you can also use it to create temporary environments. So you can actually do test environment just to test one feature and just kill everything, just scrape everything, so you don't have to spend money on the whole thing running all the time. Well, obviously it's documented, so you know what things were on and what things were not on, and what features did you turn on, because now we have to recreate a Kubernetes cluster, enormous, huge Kubernetes cluster. We don't know what config was, like what's the network configuration, what's that, what flags were on. Well, obviously it's automated, right? So because, well, it's there and can be rerun. The downside is it's not write once and forget it forever, as a lot of people management sometimes would think. You need to maintain that, because the new features, new versions, new everything, it will break things, so you need to maintain it. It will break. It will be painful at some point, but believe me, that pain is nothing compared to, I have no idea what happened 7 years ago, and nobody who's here left. Everybody who was there 7 years ago left, and everybody's new. That's much worse pain than just like, oh, it's failing. I need to look up that failing code and fix the code or fix whatever. So infrastructure as code, whatever. Again, whatever you want, but just use something. So you want to go Terraform, OpenTofu, Pulumi, anything, cool. Just use it, but do use it. Configuration, yeah, don't write your own stuff. There are a bunch of libraries that handle configuration. So one of them is microprofile config, but again, I'm not going to sell you exact microprofile. There's a bunch of other things that handle config. You can also create like property files and hierarchy, and then you can do like different properties per environment, per different things, and everything becomes very beautiful and pretty. Unicorns and rainbows and all that, the usual stuff. The last thing is infrastructure. So not all of us are super big tech companies. We do not need the Kubernetes clusters for our little chat with my cat application or something. Probably that one cat does not create enough traffic to have like a 3-node Kubernetes cluster with, all the scaling and all that. Probably you don't need that. I mean, it's like, it's also the same applies at work. Sometimes people just go like, everybody's doing Kubernetes. We just have to do Kubernetes as well. Maybe not. Have a active kind of relationship to that. You want to go with infrastructure as a service. You want to go with like bare metal, renting that. Or you want to go platform as a service, renting a little bit higher level. You want to go serverless. You want to go virtual machine, good old way. That's how we used to do stuff back in 20 years ago. We would just have a VM or maybe even physical machine, install Tomcat on it, install a jar or a war or whatever on it, and just run the whole thing. Maybe you need that. Maybe you have a very special case for that, but do have a good case for that. It's not just because it's cool and we're doing like CV-driven development, which is, can be useful sometimes, but maybe not. Right. So, yeah, 2 more minutes, good. Demo time, where's the code? Yeah, here's the code. So there's quite a few things that you can actually have a look at, and there's quite a few fun things that you can look into each of the applications. So both applications are Java applications. They're running on Quarkus. It doesn't have to run on Quarkus, but I did just for the heck of it because it was fun. And it has a lot of fun things in the Docker files, so you can also have a look at this. This is not part of this talk, but it's still fun. Where you can do multi-stage builds, where you can do, for example, if you do not want to download the whole internet every time you're building, so this is a little hack to do that. So you actually create, you download internet once, and then you actually try to do something with your code. So because of the layers in Docker and all that, I mean, we can talk more about that later. If it doesn't make sense, come to me, I'll explain. But there is a bunch of nice things that you can do. For example, this is multi-stage build as well. So you're building things with MAME and then throwing everything away and deploying it to Quarkus. Everything that I've talked about and all that is in a README file and with links to actual code. And let me see, where is my browser? There is my browser. All that is in a public repository called 5 Features Talk Demo. And here you can also see all the endpoints to local host that you will deploy and will be there. But also, after you deploy, you can actually click to them, and then it will go to the right thing. Same thing goes with to the code. So there is another handy file called Wiki. And Wiki file actually has all these 5 things that we talked about, and then you can actually go to, so this was the liveness probe for response time. If we zoom in a bit, let's see, 24 seconds, that's good. Yeah, so you remember the message that you got that it's too slow? That's this one, that's from here. And that's what it does. It just basically, you just do, you just either do response builder .down or response builder .up. That's it. So there's a lot of things that framework will figure it out and fix it for you. Yeah, okay. I think we will call it a day very soon. What else? So health, metrics. Yeah, so feature toggling, you can also see how it's done in the code. It's not very magic. So this is how you create an object that you will be calling and referring afterwards. Put a proper API key, don't do that. And then you can just call that and check. So the other thing is that kind of slightly unrelated thing, but it's really, really fun to be back in Trondheim. And yeah, this is architecture. This is me. This is my contact information. And this is the repository. And the other fun thing that I figured out was that last time I was at TDC, that was exactly 10 years ago. So it was in 2014, and now I'm back again. So it's really fun to be back and great to have you all here. Please feel free to ask any questions now, outside, or online, and I'll be here for the rest of the day. Thank you.